How often do you get to say you work next to a robotic system that's going to Mars, right? There's not many places in the world that you can do this. My name is Eric Aguilar, and I'm working on a robotic system that will be collecting Martian rock samples so they can be studied on Earth. This is our hexapod test bed. It's basically a rover body that allows us to attach, the robotic arm, the adaptive caching assembly, the drill. So that's where a lot of the testing happens behind me. The sample caching system will use a robotic arm and drill to actually take samples out of the ground. And we're looking for evidence of life that may have existed on Mars. The smaller arm that lives inside the belly of the rover and is used to actually process the tubes as they come back with a sample inside. We'll measure it, take some pictures of it, and get it sealed and stored for a future mission to pick them up. You see the robotic arm stretched out, and we have a bunch of engineers and technicians working on installing a model of our drill. Working in aerospace, that was always a passion of mine. What really draws me towards it is the engineering of it. Always working on something new and something that's never been done before. Finding those problems, getting them fixed is really something that I enjoy. In 20 years, the children will be reading this in their science book, and I kind of cherish that.
Hi, I'm Raquel Villanueva with NASA's Jet Propulsion Laboratory in Southern California. JPL is where the Mars 2020 mission and Perseverance rover are managed. Now, getting to Mars is a test of perseverance in itself, and we are joined today by one of the many faces behind the spacecraft. Eric Aguilar is the Mars 2020 Assistant Delivery Manager for the Sample Caching System, and he's also the system's testbed manager. Through extensive testing, he's making sure Perseverance will be able to fulfill its mission on Mars. He joins us live to answer some questions, and if you have any questions you would like to ask, you can leave them right here in the chat. Thanks for joining us today, Eric.
All right, thank you, Raquel.
Well, great. I want to get started with what we were talking about earlier. How did your family influence your career path?
So my family was a huge influence on my career path. My dad immigrated from Costa Rica to the United States. And my mom's side, my grandfather immigrated from Mexico to the United States. Eventually my parents met in the Los Angeles area, and I was born. But that sort of drive and need to have, provide for your family and give them more opportunities than you had, I think it's something that has always stuck with me and has helped drive my career. My parents were very influential on making sure that I, went to school to get all the opportunities I could get to, right? Study hard, get to college. That they're, being, immigrants or from an immigrant family, it's really been, a testament on how hard they work and to provide for us, right? So, I take all of that work ethic that they've instilled in me and use it every day for when we're working at JPL, from, making sure that, when we have difficult parts of the mission that we're trying to design or work through, that we can just push through and really get over the hump and really get everybody motivated and going, right? And so they've been a huge influence on my life and getting to where I'm at today at JPL, and I thank them for that.
Yeah, my father is from Bolivia, so I understand what you mean when you say that work ethic is so strong, and I'm sure they're really proud of you right now. Ed, can we kind of get more into what you studied at school and your path to JPL?
Yeah, well, so I went to Arizona State University, where I graduated with a bachelor's in electrical engineering. I eventually got a master's in business from University of Redlands. But when I was in school at Arizona State University, I also started working part-time as an academic part-time for Honeywell Aerospace. There I was working, near full-time, about 30 hours a week, plus taking a full load at ASU. And in doing so, I was able to, help pay for my college and get through that. But then I eventually, started working for them after I graduated. However, I still really had, what do I want to do? Like, I really want to be in aerospace. That's been a big passion of mine, growing up. And so I started looking for work outside of Honeywell and in the aerospace area. And I found a company in Pasadena that turns out was a contractor to JPL. And so I interviewed with this company and, obviously got hired. And then I moved to Pasadena and was working for JPL as a contractor. And my first job through this contracting company was working on the Mars exploration rover, Spirit and Opportunity, and building and working on the schematic captures for their rover electronics module. And that was something that that started off my career. Ever since then, I've been on Mars Science Laboratory, the Dawn spacecraft, now Mars 2020, and I've been here over just about 20 years now. It's been quite a ride, and quite an enjoyable ride at that.
Wow. So is this your favorite mission so far, you'd say?
Yeah, I think they're all my favorite, but yeah, this one has been a challenge, right? From working on the sample caching system, developing a robotic system, to capture samples on Mars has been outstanding, and I think it's been more just the team environment that we've been able to build, within both tasks, both the sample caching and the system test bed. I get a chance to work with a lot of incredible, talented engineers, and we're able to really come together and get this thing going. So, yes, I think that's what makes this one of my favorite projects that I've been able to work on.
And you were kind of mentioning that troubleshooting is a big part of your job. So what kind of hurdles have you had to overcome when you're testing?
Yeah, so troubleshooting, testing, finding problems, that's exactly what I live for when I work on these missions. The idea is that if we can flush it out here, we can fix it, we can mitigate it, we can get it ready to go, so that when we get to Mars or our final destination, we would know, we have confidence that this thing that our spacecrafts are going to work. And so one of the issues that I'll bring up that we've had recently, or over the time with developing the sample caching system, is within the robot is in the drill. On the drill, we have these ball lock mechanisms that are used to hold the drill bit in place as it, sort of as a gripping mechanism. Now, when we're working with rocks, you're going to have fine powder, and as you're drilling into the rocks, you're going to have this fine powder. Well, this fine powder kind of can get and creep into crevices. It's almost like when you go hiking and you start walking the trails, and you start to kind of climb higher and higher into your mountain trail. You start to find out that your hiking boots might actually get a little bit caked of some of this finer dust as it kind of sits in there and gets in these crevices. Makes it for your shoes to be a little slippery. So what you do is, is before you go on a narrow part of the hike or of the trail, you're going to tend to kind of kick your shoes a little bit and get that dust off, and that way it gives you a nice clean grip, and you're back to where you wanted it to be with your shoes. So imagine the same thing where you have this powder that's flowing as we're interacting with rocks, and you got a dusty and Mars environment. We have this really fine powder, dirt that has been kind of being pushed around and circulating around the drill as we're operating in it. While this powder is getting into some of the crevices around the ball locks, which is not letting them move as freely as we like. So during one of our tests, we were trying to go and pick up a bit, and we were unable to get past the ball locks. We eventually can show that if we push on it hard enough, it'll work, but we want to understand why were the ball locks not free as we would have liked them to be. So we're able to break our chamber and break the chamber open and go and take a look inside. And as we look inside, we notice that there's this fine powder material around the ball locks, and we realize that we have a mitigation plan already that we can employ. One of which is we call the percussive cleaning. When we get to Mars, one of the early things that we're going to do on the surface is to get the drill and do a percussive cleaning, which is using the hammer that's built into the drill to sort of shake loose any loose particulates that may have traveled with us from Earth to Mars, and get it off the drill before we start trying to do any sampling. And then, so we decided that we're going to use that similar approach on the drill to help clear out any of this fine powder from these ball locks. And once we did that, we're able to get the ball locks to actually operate back into I'll say a clean state, and they moved freely again. So it was something that we discovered here because we needed to really interact with the rocks to see it. And it's now something in our repertoire to fix or to use while we're on the surface to help mitigate this issue.
And someone on social media actually has a really good follow-up question to that. Abdul on Facebook wants to know, is the Martian ground sand or clay?
It's actually a mixture, right? So there's actually a wide range of types of rocks that we interact with. There are clays for sure. There are some mudstones, which is more like a clay. Harder rocks. We also have regolith, which is just like a sand consistency that you might see. So we actually have a wide range of rocks that we have to be able to interact with and to take samples. So we've actually developed algorithms to ensure that we don't break the samples up too much as we're trying to take a core sample. So depending on how hard or soft the rock is, we'll change our spindle and our percussive frequency to adapt to the varying types of rocks that we might interact with.
And Tracy on Facebook wants to know more about the samples. She wants to know, will Perseverance actually bring samples back to Earth?
Right. So Perseverance is not the return mission. So our job is to actually go and collect the samples, whether it's a regolith, a sand material, or actual rock samples. Once we actually take the rock sample out of the ground, we'll then hermetically seal the tube. The tube will eventually be dropped off at a site where a future mission would be able to come and pick it up and potentially bring the samples back. But our job is to actually collect the sample and keep it hermetic and make it hermetically sealed for a future mission's return.
Then Emily on Facebook wants to know about that. Will the collection techniques for Perseverance on Mars be similar to the way OSIRIS-REx sampled Bennu?
No, it's a little bit different. So we're actually taking a coring drill to go up to about 70 millimeters deep into a core, into the rock, for instance, right? So we're actually planning on taking core samples out of the ground, whereas I think in OSIRIS-REx, it's more of they do some ingestion of the sand around them where they landed, and it's more like a contact science there. Ours is to actually we will do some science ahead of time so we know which rocks we want to pick up and sample, but we're actually going to go in and take a sample out of the ground. It's probably about the width of your pinky, or at least my pinky, and about that size too, as far as how much sample we're going to get out of the ground.
Huh. Never thought of it that way before. And thank you, Emily, for keeping track of several missions at once too. And now we have Sandy on Facebook asking, what will we be able to learn about the samples collected prior to bringing the samples back to Earth for further study?
So we have a couple different instruments that will be doing X-ray spectroscopy to actually determine what sort of content might be in those rocks, right? So the idea is that we're going to go around and we are going to look, at different rock samples. Now, right, rocks may have different shapes and may look a little bit different based on where they're at, but some of the chemical composition may be the same between rocks that look different. So the idea is that we're going to actually go ahead and we will do potentially an abraded patch first, where we might clear off some of the initial, I'll say, the weathering that's happened on Mars over the time, and get down and make a judgment on whether or not we actually want that rock. So the scientists have a whole collection of instruments that they're going to use to pick up, decide which rocks they want to bring home.
And then this one is from Mike Kiki, and it kind of goes back to what we first touched on. They ask, Did you always have a love for jet propulsion and or the aerospace engineering industry?
So I'll be a little embarrassed on this one, right? I think my initial love was aerospace because I didn't know that the jet propulsion existed in the way it does today, right? So now that I'm at JPL, it's, by far this is where I want it to be, nowhere else, right? So this is one of those things where, I just didn't know. I was not um, as keyed into, the different centers and what everybody does, but the work that we do here, the our ability to be hands-on and work and design and build and get your hands dirty, that's what really makes it for me. So yeah, so as much as I'd like to say JPL was always my go-to, my number one, I just wasn't aware of it when I was first getting out of college and looking around. So yeah, so I guess aerospace, but JPL opened my eyes to the how fun this work could really be.
It's okay admitting that you didn't know. Lots of kids that are watching right now might wonder, how do you get involved or how do you learn about the different types of engineering that's involved in the industry?
Well, I mean, the thing is, there's probably every type of engineering that you can imagine and science is part of JPL. I know that I've talked to people that develop software, electrical engineering, of course, mechanical engineering, aerospace, chemical engineering, from, chemists to physicists. I think we probably hit the range. I don't know that there's an engineering discipline that you can probably ask, is this one that's relevant to JPL? Then we'd say no, because we do rely on outside, thinking out of the box and bringing in outside, I'll say, views into solving some of these problems. They're not all just kind of black and white and purely mechanical, purely electrical. There's robotics. I mean, it's all over the place, and so I don't know that there's a bad engineering. It's more making sure you do something that you really enjoy, because that's where, when you really enjoy what you're doing, that's where the work really shines, and that's where we're able to really show that, how exceptional our work can be, because I think everybody that does the work here really enjoys their engineering, and they have a passion for what they do.
And then Nabil on YouTube wants to know, how did you develop your soft skills?
Oh, a lot of trial and error. It was, I've had to, work with teams, right? We always work with teams. We work as a fairly large, community of engineers, working to get things through, and over time, I've made my mistakes and maybe come down a little too hard on somebody, or vice versa, and so I've learned, and I try to learn from other managers that I've worked for. I may take a piece from one manager and a piece from another one, and try to get that to sort of become mine. And so yeah, it's a learned process, and one thing I think I've learned at JPL is we're not afraid to make mistakes or to get something wrong. We just want to learn from it, and then move on and do better about it the next time. So I think I'd say I learned it on the job, and interacting with the teams, and emulating some people that I admire at JPL.
That's great. And Lisa on YouTube wants to know if you have any tips for women wanting to get into engineering.
Well, I mean, it's same. I'll say the same thing, right? Is make sure you enjoy what you're doing. If you have the passion for it, I know there's been a lot of females on my teams for sure, and I'll say they're just as good as everybody else, right? Oftentimes I feel that they come in and they bring in a solid understanding of everything that we do, as coming in and just kicking butt, right? I'm a proud dad of two girls, and I can't wait to see them get out there and make an impact.
This is great. Proud girl dad over here. And how is testing coming along, as C on YouTube asks? Are you still testing right now?
Yes, that's one thing I think that we always do, right? We test and test and test because we want to find all the corner cases. We want to make sure this thing is going to work. Um, when we go and in an unknown environment, right? We don't know what we might encounter, right? So we want to test. We want to test as much as we can. So we will be testing, our entry, descent, and landing. We're going to be testing that all the way into just about we land, and making sure that our software, our sensors, everything is robust to anything that we might see coming in. Additionally, we have rocks that we're still working and testing with our sample caching system. We're still making progress there, and we're still trying to define, all the corner cases and making sure that there's nothing that can surprise us on Mars. We want to, oftentimes we try to stress the system out and get to its, 3 times life on things that move. We want to make sure that if it was designed to last a year, that we can actually operate it for 3 years to make sure that we have a robust design that can complete the mission as planned. So yeah, we always test, and like I said, this is something that we do all the time, right? We really just plow through and test and test and test. I don't think we ever get tired of that.
And Catherine has a perfect follow-up question for that. On Facebook, she asks, when designing and engineering this project, were the same ideas used from curiosity, or do you start it all from scratch?
That's a good question. This mission was, curiosity was a basis for building this rover. So we try to reuse a lot of the electronics and some of the hardware, the mechanical structures that we could fit. And part of it was, we're getting to the point on our current technology of how big we can actually have these rovers, what's the mass that we can safely land on another planet. And so we want to kind of stay within those constraints. The sample caching system, however, was brand new. So that was something that we had to develop from scratch, if you will. We did have the robotic arm and the drill, or a version of the drill from MSL, Mars Science Laboratory. But we actually had to make improvements on that to make sure we were able to meet the mission requirements, right? So every part of the sample caching system, I would argue, is new, whether in redesigning and making it lighter, like the robotic arm did, or making a more capable drill for what we have for taking cores, and of course all the adaptive caching assembly hardware inside the rover.
And Lisa on YouTube asks, can dust on Mars cause electrical problems?
I would say arguably maybe. We are typically, all of our connectors, wires, cables, the belly pan, everything is sealed up with, so it's going to have, we may get some dust in there. But the idea is that, we use, like for the electronics, things are typically conformally coated, which means that there's a thin film coating that gets added to all the electronics to keep things from any fault to enter and potentially damage electronics, short something out. So that's the one thing is, the dust might have an impact, but I haven't really seen it much outside of gunking up gears and things of that nature. Not so much on the electronics. But again, I don't know that I can say that for sure that dust will not have an impact on the electronics. But yeah, so it's a soft answer.
It works, though. I have a follow-up question to that. They want to know, does it ever get frustrating testing so much?
Yes, it does sometimes. Because sometimes it's because the problems come up and they're really hard to figure out and diagnose. Coming to the root cause of the problem is sometimes, extremely difficult, and so it gets a little frustrating sometimes. But I know over the years that I've been working there, I've learned how to sort of take a step back from time to time and just kind of take a step back and take a breath and say, okay, this is what you're doing. You're working on a rover that's about to go to Mars. Okay, take a deep breath. Now get back into it and don't let this problem beat you, right? So that's one of the things that I think, it gets frustrating sometimes, but I think if we just all take a step back and a breath, we can overcome these problems. And in general, we might have a problem that shows up, but typically we've already known about it and already ready to mitigate it as it comes out. So it's a little frustrating sometimes.
It's to be prepared.
Yeah, exactly.
The final question we have is, what technical skills do you think are the most important, especially now that you're leading such a huge project?
Oh, technical skills. I think one of the biggest things is to rely on your team. It's not so much a technical skill, right? My expertise is in electrical engineering, integration and test, and some of the system designing. But I don't know everything, and I don't pretend to know everything. So I make sure that the team is comprised of folks that are willing to be collaborative and want to work together. And as a team, we come together and make the right choices. And oftentimes, I may have to make the last decision on something before it goes to my boss to decide. And so it's the ability to, understand the different points of views, try to synthesize all that, and then make a good decision that, is beneficial to the project and not just, set aside because that's the way I want to do it, or I just don't understand something. So, I think I don't know if there's any real technical stuff. I mean, when it comes to electrical stuff, electrical engineering, I am definitely there and providing my opinion and where we're at. But when it comes to, potentially a mechanical failure that, I have to rely on the folks on my team that are experts or in that area to help guide the decision process, right? So I don't know if it's just, it is technical to actually be able to understand everything, but it's more, I'll say it goes back to some of the soft skills, as being able to synthesize all that and come to a good consensus.
This is a great way to wrap up all the questions. Thank you for your questions at home, and thank you so much for joining us today, Eric.
Thank you, Raquel.
And the rover is currently on its way to Mars and set to land on the red planet on February 18th, 2021. For the latest on the mission, follow at NASA Persevere on Twitter and Facebook. And you can watch all of the Behind the Spacecraft video profiles on the NASA 360 YouTube channel. Thanks for joining us today.